What if I told you, our sun isn't just small, it's practically invisible on the cosmic scale? Setting the stage, this is Earth. About 8,000 miles across. Tiny, compared to the star it orbits. Our sun? Nearly 110 times wider than our entire planet. To us, that feels massive. But out there, in the real universe, it's barely average. Enter Rigel. Meet Rigel. A blue supergiant blazing in the constellation Orion. This star is roughly 70 to 80 times wider than our sun. If you swapped the sun for Rigel, its surface would stretch well past Mercury's orbit. From Earth, the sky wouldn't just glow, it would burn with a bluish-white furnace, filling nearly half your view. Betelgeuse enters, but Rigel? It's still playing in the minor leagues. Say hello to Betelgeuse, one of the largest red supergiants ever observed. This monster is so huge, if you placed it where our sun sits, its outer layers would reach almost to Jupiter's orbit. Every planet inside, Mercury, Venus, Earth, Mars, gone. Vaporized. View from Jupiter. Now imagine you're standing on Jupiter. Look up. There's no tiny yellow dot in the sky anymore. Instead, a wall of incandescent gas stretches across the entire horizon. A star so enormous, it makes the entire solar system feel small. Stephenson 218, but Betelgeuse? Still not the champ. Meet Stephenson 218, the largest star humanity has ever discovered. This red hypergiant is mind-bending. About 2,150 times the radius of our sun. Swap Betelgeuse for Stephenson 218, and its outer layers blow past Saturn's orbit. Even Jupiter disappears, deep inside the star itself. View from Uranus. From Uranus? The sky is almost entirely covered. No stars. No blackness. Just a glowing, crimson dome of stellar material, stretching in every direction. The quasi-star. This is close to the largest star we've ever observed. Or, so we thought. Meet the quasi-star. Unlike everything you've seen so far, this one has never been observed. Not once. Quasi-stars are entirely hypothetical, objects predicted by theoretical models of the early universe. There's zero direct evidence they ever existed. But if those models are right, they may have been larger than any star we've ever discovered. Replacing the sun. So, what happens if we replace our sun with a quasi-star? Everything from Mercury to Pluto lies deep inside its enormous outer layers. Even from half a light year away, its apparent size would still exceed that of the full moon. Instead of a small white disk, our skies would be dominated by an enormous crimson star. If such an object had ever existed this close, our planet would never look the same again. Galactic scale. As impossible as a quasi-star may seem, it's still tiny compared to what comes next. Our own galaxy, the Milky Way, stretches more than 100,000 light-years across. At that scale, even an object hundreds of astronomical units across becomes almost impossible to notice. The universe's perspective. The universe has a way of reminding us, No matter how big something seems, there's almost always something even bigger. Earth feels huge, until you compare it to the Sun. The Sun feels massive, until you meet Rigel. Rigel feels enormous, until Betelgeuse enters the frame. And just when you think you've seen the limit, Stephenson 218, quasi-stars, and entire galaxies rewrite the rules. Why this matters: this isn't just about big numbers. It's about perspective. Every time we push the boundaries of what we know, whether it's the size of a star or the edge of the observable universe, we're reminded of how much is still out there, waiting to be discovered. Science is evolving, and here's the thing: science doesn't stand still. Yesterday's largest star can be tomorrow's footnote. New telescopes, new data, new models, they keep reshaping our cosmic address. What we call the biggest today might be dethroned next year. Human curiosity, that's the beauty of astronomy. It's not just about facts and figures. It's about wonder. It's about looking up and asking, what else is out there? How much bigger can it get? And, are we even close to the limit? Bringing it home so next time you see the sun in the sky, remember, it's not small. It's not insignificant. It's the reason we're here. But out there, in the vast, dark, beautiful universe, it's just one star among hundreds of billions, in one galaxy among trillions. The takeaway: here's your one memorable takeaway. The universe doesn't do big. It does unimaginably bigger. And every time we think we've reached the edge, it turns out we were just getting started.
If you enjoyed this video, please like, subscribe to Palsa Lab and turn on notifications so you don't miss our latest uploads. At Palsa Lab, we explore space, science, astronomy, AI, and emerging tech, bringing clear explanations and fascinating discoveries. Have a question or idea? Drop it in the comments. Stay curious, keep exploring, and thanks for watching. See you next time.